Imagine a world so enormous that if you hollowed it out, you could pour every other planet in the solar system inside it. Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, and there would still be room left over. A world where winds howl at 600 kilometers per hour and never stop, where storms larger than our entire planet have been raging for centuries without pause, where a retinue of moons orbits like a miniature solar system unto itself. You have seen its photographs. You have heard its name since childhood. You thought you knew it. For decades, so did the scientists. And then something appeared in the data, something that turned Jupiter from a familiar giant into an urgent mystery. The instruments aboard NASA's Juno spacecraft, which has been threading through Jupiter's lethal radiation belts since 2016, detected an anomaly. Not a small one. Not the kind you file away as noise and revisit later. A gravitational signature that did not match any existing model. A magnetic reading so far outside predicted parameters that it forced researchers to question whether the interior of the largest planet in our neighborhood is anything like what we imagined. And beneath that first anomaly, another emerged, and then another. Layer after layer of wrongness accumulating in the data, each one more unsettling than the last. If this kind of exploration fascinates you, if you want to follow this descent into one of the most disturbing discoveries in modern planetary science, subscribe to the channel, leave your like, and stay with us. Because what comes next changes everything you thought you understood about Jupiter. Here is what makes this genuinely disturbing. Jupiter is not a rocky world you can drill into. You cannot land on it. You cannot sample its soil. Below those swirling photogenic clouds of ammonia and hydrogen, the pressure climbs with such ferocity that the very nature of matter transforms. Hydrogen ceases to be a gas. It becomes liquid. Then, deeper still, it is crushed into something even stranger. Metallic hydrogen, a substance so exotic it barely exists anywhere else in the known universe. A fluid that conducts electricity and generates the most powerful planetary magnetic field ever measured. And at the center of this abyss, thousands of kilometers beneath the visible surface, there may be a core. But what kind of core? Solid, diffuse, something no model has ever predicted? The latest data from Juno suggests the answer is none of the above. Something inside Jupiter appears to be moving, restructuring, changing in ways that should not be possible on any timescale a human could witness. The model said these processes take billions of years. Slow, imperceptible, geological in the deepest sense. But the readings say otherwise. The readings say it is happening now. And when scientists at NASA began using the word concerned, the rest of the world should have listened more carefully. Because what is stirring inside the largest planet in our solar system is not just a scientific curiosity. It may be the first tremor of something we are not remotely prepared to understand. To grasp what is happening near Jupiter, you first need to feel how large it truly is. Not as a number, but as a sensation. Take the Earth, hold it in your mind. Now imagine placing it on the surface of Jupiter. Our entire planet, every ocean, every continent, every mountain range, every city that has ever existed, would be smaller than the Great Red Spot, a storm that has been churning since before your civilization learned to write. That storm alone could swallow the Earth whole and barely notice. And the Great Red Spot is not even the most remarkable thing about Jupiter. It is merely the most visible. Now go deeper. If you could somehow descend through Jupiter's atmosphere, past the ammonia ice clouds, past the layers of hydrogen gas that thicken with every kilometer, you would not find a surface. There is no ground. There is no moment where you stop falling and start standing. Instead, the gas around you simply becomes denser, heavier, more oppressive, until the pressure becomes so immense that the distinction between gas and liquid ceases to exist. You would be crushed long before you reached that transition, of course. At a depth of roughly 1,000 kilometers, the pressure already exceeds anything on Earth's surface by a factor of hundreds. But the planet does not stop there. It continues downward for another 69,000 kilometers to its center. Picture this. If you stack the distance from New York to London end-to-end 12 times, you would still fall short of spanning Jupiter's radius. And at each step of that descent, the environment becomes more alien, more hostile, more fundamentally unlike anything that exists on our world. The hydrogen that fills Jupiter's upper atmosphere is the same element that fills balloons at children's parties. But squeeze it under millions of atmospheres of pressure, heat it to temperatures rivaling the surface of the sun, and it becomes something else entirely. Metallic hydrogen, a shimmering, electrically conducting fluid that no laboratory on Earth has ever managed to sustain for more than a fraction of a second. Inside Jupiter, this substance exists in quantities so vast that it generates a magnetic field 20,000 times stronger than Earth's. A field so violent it would fry the electronics of any spacecraft that lingered too close. And it is precisely within this impossible environment, this place where matter behaves in ways we can barely simulate, where pressures erase the boundaries between states of existence, that something unexpected is happening. The Juno spacecraft, orbiting above, can measure the gravitational pull of everything below it with extraordinary precision. And those measurements are telling a story that does not match the script. The mass distribution inside Jupiter is shifting. The interior architecture of the planet appears to be in flux. Something down there, in that realm of metallic oceans and unimaginable pressure, is rearranging itself. And we have no clear explanation for why. But Jupiter's interior is not the only place where the unexpected is unfolding. Look outward, toward the moons, and the picture becomes even more unsettling. Because the worlds that orbit Jupiter, that gravitational court of ice and rock and fire, are behaving in ways that no model predicted, and the timing of their anomalies is impossible to dismiss as coincidence. Start with Europa. You may have heard of it. The smooth, ice-covered moon that harbors a liquid ocean beneath its frozen shell, an ocean that contains more water than all of Earth's seas combined. For years, scientists have mapped Europa's surface, cataloging the network of cracks and ridges that suggest tidal flexing, the slow breathing of a world being squeezed and released by Jupiter's gravitational grip. But the latest thermal readings show something new. Regions of Europa's surface that should be completely inert, areas far from the known fracture zones, far from any predicted source of internal heat, are warming, faintly but measurably, as though something beneath the ice is stirring in places where nothing should stir. Then turn to Io. If Europa is a world of silent oceans, Io is its opposite, the most volcanically active body in the entire solar system. A moon so tortured by gravitational forces that its surface is constantly being torn apart and rebuilt by eruptions of sulfur and silicate lava. Scientists have tracked Io's volcanic cycles for decades. They know its rhythms, its patterns, its seasonal intensities. And those patterns are breaking. The eruptions are accelerating. The output is increasing in a cadence that fits no previously recorded cycle. As if some invisible hand is squeezing Io harder than before, forcing its molten interior outward with growing urgency. And then there is Ganymede, the largest moon in the solar system, larger than the planet Mercury. Ganymede possesses something no other moon does, its own magnetic field. That field has been studied, measured, modeled, and now it is emitting signals at frequencies that researchers cannot yet fully explain. Electromagnetic whispers in wavelengths that do not correspond to any known interaction between Ganymede's magnetosphere and Jupiter's overwhelming magnetic environment. Something is producing those signals, and the source remains unidentified. 3 moons, 3 separate anomalies, all occurring within the same narrow window of observation. The probability that these are unrelated, that Europa's thermal spikes, Io's volcanic surge, and Ganymede's mysterious emissions are each caused by independent coincidental factors, is vanishingly small. The far more likely explanation is that they share a common cause, and that cause points inward, toward the one thing all three moons have in common: the gravitational sovereign at the center of their orbits. Whatever is changing inside Jupiter is not staying inside Jupiter. It is radiating outward, tugging at its moons, reshaping their behavior, sending ripples through a system that was supposed to be stable. And the scale of that influence is only beginning to reveal itself. Here is the paradox that haunts every scientist studying this phenomenon, the question that sits at the center of every analysis like a crack in a foundation. Planets like Jupiter are not supposed to change. Not like this. Not on a timescale that a single spacecraft orbiting for less than a decade could detect. The models of planetary evolution, the mathematical frameworks that describe how gas giants form, cool, contract, and settle over time, treat these processes as glacially slow. We are talking about timescales measured in hundreds of millions of years, sometimes billions. A gas giant forms from the swirling disk of material around a young star, collapses under its own gravity, heats up, and then spends the rest of its existence slowly radiating that primordial heat into space. Its interior settles, its layers stratify. Its core, whatever it may be, reaches a kind of equilibrium with the crushing ocean of metallic hydrogen above it. That is the story. That has always been the story. And it is a story that worked. Until the data stopped agreeing with it. What Juno is detecting suggests that Jupiter's interior is not in equilibrium. The gravitational field, that invisible fingerprint of how mass is distributed inside the planet, is showing variations that imply movement, redistribution, turbulence in regions that should have been settled for eons. It is as though the core of Jupiter is not sitting still. It is dissolving, or migrating, or interacting with the metallic hydrogen around it in ways that create measurable fluctuations in the planet's gravitational signature. And those fluctuations are not subtle artifacts buried in noise. They are clear enough to alarm the people whose entire careers have been built on understanding how giant planets work. This is the invisible limitation. We built our understanding of gas giants on the assumption of deep stability. The idea that once a planet this massive settles, it stays settled. Every simulation of exoplanetary systems, every model of how distant worlds around other stars behave, every prediction about the long-term fate of gas giants across the universe rests on that assumption. And if that assumption is wrong, if gas giants can undergo rapid internal restructuring on timescales of years or decades rather than eons, then the models are not just incomplete. They are fundamentally flawed. Think about what that means. We have cataloged thousands of exoplanets. Many of them are gas giants far larger than Jupiter, orbiting their stars in configurations we once considered impossible. We explained those configurations using models that assumed internal stability. But if Jupiter itself, the gas giant we can actually observe up close, is proving that assumption wrong, then every conclusion we drew about those distant worlds must now carry an asterisk. The paradox is not just about Jupiter. It is about every giant planet we have ever studied, every simulation we have ever trusted, and every answer we thought we already had. To understand what might be happening inside Jupiter, you need to abandon every intuition you have about how matter behaves. Down here, in the deepest layers of the planet, the rules you learned in school dissolve under pressures that defy comprehension. And the mechanisms that may be driving this transformation operate in a realm so foreign that even the physicists who study them speak in approximations and caveats, aware that their equations are reaching into territory where certainty evaporates. Begin with the core. For decades, the standard model of Jupiter's interior described a neat, layered structure. A dense core of rock and heavy elements at the center, surrounded by a vast envelope of metallic hydrogen. which gradually transitions into molecular hydrogen and then gas as you move outward. Clean, orderly, predictable. But Juno's gravity measurements shattered that picture. The data suggests that Jupiter's core is not a compact, well-defined sphere. It is dilute, spread out, fuzzy, bleeding into the surrounding layers like ink dropped into water. The boundary between core and envelope may not exist at all. Instead, there appears to be a gradient, a slow transition from heavier elements to lighter ones, with no clear line separating where the core ends and the rest of the planet begins. This alone was revolutionary. But the recent anomalies go further. The gravitational variations Juno is detecting imply that this dilute core is not static. It is convecting, churning, overturning, moving mass from deeper regions to shallower ones, and back again in cycles that generate detectable shifts in the planet's gravitational field. Picture an ocean of liquid metal the size of a small star, heated from below and compressed from above, slowly rolling over itself in currents so massive that each one carries more energy than our sun releases in a day. That is what may be happening beneath Jupiter's clouds. Not a settled, sleeping interior, but a living one. Restless, dynamic, constantly renegotiating its own architecture. And here is where the mechanism becomes truly strange. In the conditions that exist inside Jupiter, temperatures of tens of thousands of degrees, pressures millions of times greater than Earth's atmosphere, the behavior of hydrogen itself becomes uncertain. At these extremes, hydrogen exists in a state that blurs the line between liquid and solid, between conductor and insulator, between element and something else entirely. The physics of metallic hydrogen at these pressures is still poorly understood. Laboratory experiments on Earth can only sustain these conditions for nanoseconds before the apparatus fails. Everything we think we know about metallic hydrogen at Jupiter's core depths is extrapolated from theory, from simulations that rely on assumptions we cannot fully verify. So when the data says something unexpected is happening, we face a humbling truth. We may not have the physics to explain it, not because the physics does not exist, but because the physics that governs the deepest interior of Jupiter operates in a regime we have never directly accessed. We are listening to the heartbeat of a giant through a stethoscope we barely know how to calibrate. And so you arrive at the question that refuses to stay contained. If Jupiter's interior is actively restructuring, if its dilute core is convecting, its mass is redistributing, its gravitational signature is shifting in real time, then what is driving it? What force, what trigger, what unseen variable could set the interior of the most massive planet in our solar system into motion on a timescale that a single spacecraft can detect? The first possibility is almost reassuring. Perhaps this is normal. Perhaps gas giants undergo periodic internal convective episodes, moments when accumulated thermal gradients become unstable, when layers that have been slowly heating or cooling reach a tipping point and overturn. If that is the case, then what Juno is witnessing is simply the first time we have been close enough, with sensitive enough instruments, to catch one of these episodes in progress. Jupiter may have done this 1,000 times before. We were simply never watching. But this reassurance carries its own devastation. Because if internal restructuring is a normal, recurring feature of gas giant evolution, then every model of planetary formation and long-term stability needs to be rewritten. The simulations that predict how exoplanetary systems evolve over billions of years, simulations used to assess the habitability of distant worlds, to calculate gravitational influences, to determine whether Earth-like planets can survive in systems dominated by gas giants. All of those simulations assumed a stable interior. Remove that assumption, and the calculations cascade into uncertainty. The second possibility is far less comforting. Perhaps something external triggered this. A gravitational perturbation from a passing object, an interaction with the solar wind at an unusual intensity, a resonance effect among Jupiter's own moons that fed energy back into the planet in ways not previously modeled. Each of these hypotheses has been floated. None of them has survived scrutiny intact. The perturbation required to affect Jupiter's deep interior would need to be enormous, far larger than anything we have observed or have reason to expect in the current solar system. And then there is the third possibility, the one that is spoken about mostly in corridors and not yet in published papers. The possibility that we are observing the effects of a process we have not yet identified, a physical mechanism that operates in the exotic conditions of Jupiter's interior for which we have no analog, no theory, no framework. Something that emerges only when hydrogen is metallic, when pressures reach tens of millions of atmospheres, when temperatures and densities conspire to produce behavior that our physics has not anticipated. Each answer opens a door onto a larger unknown. Normality demands we rewrite the textbooks. External triggers demand an explanation we cannot find, and an unknown mechanism demands a humility that science is never comfortable with. The admission that we may be staring at something our current understanding is simply not equipped to name. Now pull back. Step away from Jupiter's swirling depths and consider what this means beyond the planet itself, beyond its moons, beyond the elegant diagrams in scientific journals. Consider what it means for us. Jupiter is not merely the largest planet in the solar system. It is the architect. Its gravitational influence shaped the very arrangement of worlds we inhabit. During the early chaos of planetary formation, when the solar system was a violent disk of colliding debris and molten protoplanets, Jupiter's immense mass acted as both shield and sculptor. It flung some objects into the outer darkness, captured others into its orbit, redirected countless asteroids and comets away from the fragile inner planets, where Earth was struggling to cool and solidify. Without Jupiter, the bombardment of the early Earth may have never subsided long enough for oceans to form, for chemistry to become biology, for the first trembling cells to emerge. In a very real sense, you owe your existence to the gravitational stability of a gas giant 500 million kilometers away. And that is precisely why what is happening now carries weight beyond curiosity. If Jupiter's internal restructuring is altering its gravitational field, even slightly, even at the margins of measurement, the consequences do not remain local. Gravity is not a fence. It does not stop at a boundary. Every shift in Jupiter's mass distribution sends a whisper outward through the solar system, a faint but real adjustment in the gravitational landscape that every orbiting body responds to over time. Asteroids in the belt between Mars and Jupiter, comets in the outer reaches, the delicate orbital resonances that keep the inner planets in their lanes. All of these are calibrated over billions of years to a Jupiter that sits still, to a Jupiter that behaves. You will not feel anything tomorrow. The effects, if they propagate, operate on timescales that dwarf a human lifetime. But the solar system does not care about human lifetimes. It operates in millennia, in epochs, in eons. A subtle gravitational shift today could alter the trajectory of an asteroid 1,000 years from now. A changed resonance could destabilize an orbit 10,000 years from now. We are not accustomed to thinking in these terms. Our minds are built for seasons, for decades at most. But the machinery of the cosmos grinds on time frames that make our entire civilization a footnote. And there is a deeper discomfort still. If Jupiter, the one gas giant we can observe up close, the one we have studied most intensely, is capable of surprises this profound, then what are we missing elsewhere? What is happening inside Saturn, inside the ice giants Uranus and Neptune? Inside the thousands of gas giants we have catalogued around distant stars? We assumed stability because stability was convenient, because it made the equation solvable, because it allowed us to sleep at night believing the cosmic architecture was settled. But Jupiter is whispering that the architecture may never have been as settled as we needed it to be. And so you stand here at the edge of what is known, looking out across a gulf that no instrument can fully bridge. Jupiter turns in the distance, ancient, immense, indifferent to your gaze. And somewhere within its unfathomable depths, something is moving. Something is changing. Something that was supposed to be still is restless. And all the models, all the simulations, all the confident diagrams in all the textbooks are quietly bending under the weight of what the data is saying. There is a temptation, in moments like this, to reach for answers, to demand that science resolve the anomaly, close the gap, restore the certainty. But perhaps the most honest response is not an answer at all. Perhaps it is simply the willingness to sit with the enormity of not knowing, to let the question remain open, vast, unresolved, and to feel, truly feel, how small our understanding is against the scale of what exists. Consider what Jupiter represents, not just a planet, not just a mass of hydrogen and helium spinning in the cold vacuum of space. Jupiter is a mirror held up to the limits of human comprehension. We sent our finest instruments across hundreds of millions of kilometers of void. We engineered a spacecraft capable of surviving radiation that would kill a human in minutes. We pointed every tool we possessed at this giant and said, "Tell us what you are." And Jupiter answered, but not in a language we fully understand. Not yet. Perhaps not for a long time. This is the nature of discovery. Not the triumphant moment of understanding, but the humbling instant when you realize the question is larger than you imagined. Every great leap in science has begun not with an answer, but with the collapse of a certainty. The moment when what was known crumbles, and what remains is raw, uncharted, terrifying, and beautiful. Jupiter is offering us that moment now. The interior of a world 300 times the mass of Earth is in motion, and we do not know why. Its moons are responding to forces we cannot fully trace. Its gravitational field is whispering secrets in a dialect we have not yet learned to read. And you, standing on a small blue world, orbiting an ordinary star, in one arm of an unremarkable galaxy, you are alive at the precise moment when this mystery revealed itself. That is not a small thing. In the entire history of our species, no generation before yours has had the instruments to detect what Juno is detecting, the knowledge to recognize what is anomalous, or the imagination to ask what it might mean. You are the first to hear this particular silence break. What stirs inside Jupiter may take decades to understand. It may reshape our models of the cosmos. It may remain, for a time, beyond our reach. But it is there. It is real. And the universe, as always, is far stranger, far more alive, and far less finished than we ever dared to believe.